Okay, so here we're looking at a modulus of a linear function. If we're talking about a vertex of a linear, so meaning a straight line graph which has been modulus, so it's flipped upwards, what we can do is if we need to find that minimum point, so we're looking for this point P, we're going to take, almost treat it like complete the square. You look at what's inside the modulus sign, and that's the bit you're going to make equal to 0, and that's what's going to show you your x value for your minimum. So that's going to give me 3x equals minus a, so x equals minus a over 3. So here my x is minus a over 3 and my y is simply a. Okay, so that's my coordinates for point P. Then it tells us to sketch the graph g of x equals the modulus of x plus 5. So in order to sketch that, what we're going to do is, let's draw some axes in. We're going to say if I had y equals x plus 5a, when x equals 0, I can see y equals 5a. When y equals 0, x equals minus 5a. So x equals minus 5a. So I'm going to say 5a and minus 5a. I'm going to join them up, but I'm not going to go past down below the y-axis because I know modulus means everything is positive, and I'm going to bounce it back like that. Obviously you'll have more space and you'll draw it as a separate graph. And then it says these two graphs intersect at 2 points, and you want to find the coordinates where they intersect. Okay, so let's redraw our graph. What I'm going to do is actually draw it onto this one to show you what we are going to do. So we've got minus a over 3 and a. This one, when x equals 0, we're going to get modulus of a, which is a, plus a. So we know this is 2a. Now if I was to have 5a, it's going to be above it, and minus 5a is going to be over here somewhere in relation to this graph. Now you can obviously draw in pencil or even draw in pen on your diagram. Now if you notice, we're told in the question, it tells us that it meets at 2 points. So what we can see is going to meet here, and it's probably going to meet somewhere up here where this side of the graph meets. Now if we think about it, x plus 5a is a positive graph. So it's talking about this bit here. The modulus, which is making the whole thing minus, would actually give you this bit of the graph, which isn't the bit that's intersecting. So all we care about is this bit here, right? Which is the original just x plus 5a. So we're going to say it's going to be when x plus 5a equals the original plus a, or when x plus 5a equals this bit which was in the modulus sign being negative plus a. Now if you didn't see it, you could consider all 4 options. So here we have gx positive, fx positive, gx positive, fx negative. We could consider gf negative, fx positive, and you would see that some of the answers just wouldn't work if you plugged it back in to both of them, if you can't see which bits you're using. So now if we solve this, put all the x's on one side, we're going to end up with 3x minus x, so 2x, 5a minus 2a, so that's 3a, so we've got, that's 2x, sorry, clearly I'm asleep today, so x equals 3 over 2a. Now if x is 3 over 2a, we can substitute that back in, so let's put it back into here. Doesn't matter which one, we should get again the same answer. So 3 over 2a plus 5 is going to give you 13 over 2a. So then my coordinate here is 3 over 2a and 13 over 2a. And I can double check that putting in f of x and showing that it works. Here I get x plus 5a equals minus 3x minus a plus a. These are going to cancel. So I'm going to get 4x equals minus 5a. And so x equals minus 5 over 4a. do exactly the same thing, substitute it back in, and you get 15 over 4a. And those are your coordinates. Right, so I hope that helps.